Dear students, today we will be discussing about grid connected PV system. Okay. So, basically we will discuss functioning and layout of a grid connected PV system, different components of a grid connected PV system, then selection of different equipment, role of different components for maximization of PV system efficiency. Okay. So, what is grid connected PV system? A grid connected PV system is made up of an array of panels mounted on metallic support or integrated into a building. Okay. The panels are connected in series and parallel to achieve optimal voltage and current and feed into the inverter, which transforms direct current into alternating current at a phase and at the same voltage as the grid. The operating voltage of an array of panels is around 150 to 400 volt DC for small systems of capacity 1 to 3 kilowatt and 400 to 700 volt DC for inverters of capacity varies from 10 to 500 kilowatt. And the maximum voltage is generally limited by the problems of insulating panels to avoid any current leakage and the maximum voltage accepted by the inverter. These two are very important. The inverter will be equipped with a MPPT system that constantly adjusts the entry voltage, because this will vary with solar insolation and temperature. So, now see the basic flow diagram of a grid connected PV system. So, we have sun, so electromagnetic radiation will come and strike on the PV surface and then we can generate DC current, right. So, then that has to be converted to alternating current by using an inverter. So, we need an inverter to convert DC current to alternating current, then that can be connected to some load. Okay. This is called AC load, and if we have generated more energy, then through meter we can give it to the utility grid. So, daytime, suppose in a household we are generating energy through this PV system and we are not utilizing it. So, what we can do? We can provide the energy to the utility grid. At the night time, since we do not have any battery backup, so we can take the energy from the utility grid for meeting the demand, right. So, that way we can take. So, this is known as net meter. Okay. This will take care of the amount of energy what is given to the grid and the amount of energy which is taken from the grid. Okay. That is called net metering system or net meter, right. So, this is a very basic flow diagram of a grid connected PV system. So, there are two general types of electrical designs for PV power stations, and the first design is without battery backup and second design is with battery backup, right. So, components already it is known to us now. PV arrays we need, then we need MPPT because we need to operate at maximum power point, okay, by using the electrical or mechanical system, and then we need to have inverter to convert direct current to alternating current and then grid interface. Okay. So, if we are done with this, then we can give it this power to local grid or we can give it to utility grid. Okay. So, similarly same thing happens, only sense is here one storage system. Okay. Energy can be stored whenever required and that can be delivered as per the requirement. Okay. Now, this figure shows the layout of a grid connected PV system. Okay. As we have discussed, this energy from the sun is received by this PV array, okay, and after generating this current, that has to be transferred to this inverter. So, different kinds of inverters are there, we will discuss in the coming slides. So, if we use central inverter, then this DC current will connect to this combiner box, then it goes to inverter. Again we need DC cables, okay, and as we know the function of an inverter is to convert this DC input to the AC output. Then from here it goes to transformer and then it will go to grid. So, when it goes from transformer to grid, then we will use high tension cable, and from inverter to transformer we use low tension cable. Means low tension means at lower voltage, at lower V is voltage and current is high. Okay. For in case of high tension cable, so voltage is high, but current is low. Okay. And sometimes other inverters are also used, maybe string inverters. So, in case of string inverter, what happens? So, we need a AC switch gear, okay, before it goes to transformer. Okay. So, we learn all different kinds of inverters in the coming slides, but this tells about how this system works. Okay. We need solar energy and then PV modules or arrays, okay, and we need different cables like DC cables, okay, AC cables, then inverters, okay, transformers and then grid, right. Now, let us see what are different components involved in this grid connected PV system. Okay. So, primarily we have three components: electrical components. So, under electrical components we will have PV modules, then power conditioning units, cables, combiner box, then connectors. Okay. Next thing is civil and mechanical components. So, under civil and mechanical components we will have module mounting and structures, then mounting foundations. Okay. And third category is power monitoring components, which includes Scada and weather stations. Okay. Now, we will discuss one by one. So, solar module, already we know that 90% of the solar modules are made of silicon based solar cells. It may be single crystalline or may be multicrystalline. Okay. So, we need to select the best module for the particular applications, right. So, this configuration is for single or monocrystalline silicon solar cells, and already we know how it look likes. We also studied the crystal structure and why it looks something like this, and also we have studied the conversion efficiency. It varies from 15 to 19% for monocrystalline silicon solar cells, and this silicon is formed into bars and cut into wafers in case of single crystalline or monocrystalline silicon solar cells. In case of multi or polycrystalline silicon solar cells, configurations is something like this, and we can get this kind of picture because of these grains. There are many grains, and this conversion efficiency is about 12 to 15%. Okay. So, mostly these multicrystalline solar cells are used in many of the solar power plants, okay, because of the cost. Okay. Here in monocrystalline solar cells we will have higher cost, and we have to invest more for purchase of this module. Okay. Also, we know these fragments of silicons are melted together to form wafers. That is known to us. Already we have studied how these cells are manufactured and why their configurations are something like this. Okay. So, there are some criteria for choosing grid connected panels. Okay. What are those criteria? Reliability and reputation of the manufacturer is very important, because once it is installed, that has to work for 25 years, minimum 25 years. Okay. Good price, of course. When we are investing something, we must know the price if we are getting at a lower rate, but without compromising the other parameters, then always it is welcome. Then closely power matching modules. So, power has to be matched. So, when we solve problems, then you will understand what does it mean, power matching modules. Then good mechanical quality, well designed frame and easy to install panels. These are very important aspects, and good quality connectors, then cooled anti-return diodes with a junction box designed to dissipate their heats in case of hotspot generation. This is also important. Okay? Sometimes hotspots are generated, as we have discussed in the class when we were discussing about the modules. So, how hotspots are generated and what are the alternatives technique to remove these hotspots. These are attached to this system. Okay? Now, come to the inverter parts, which is one of the key components for functioning of a grid connected PV system. So, this major component in grid connected PV system is the DC-AC inverter, or also known as power conditioning unit or PCU. It looks something like this. Okay? These are the photographs of this PCU. Okay? Already we know what is the function of an inverter. It converts direct current to the alternating current, right? So, if we compare with the inverter what is available for standalone, there are some differences. So, what are differences? So, in case of the inverter used in grid connected system, it must be a sine wave frequency, and AC voltage to be fed into the grid must be in phase with it. Okay? And it must comply with the number of regulations and safety requirements which are more demanding than standalone system. Okay? All inverters are connected to the grid incorporates MPPT. So, here this kind of inverters, MPPTs are attached with it. So, there are some factors which must be considered when selecting an inverter. Okay? So, what are those factors? Like power conversion efficiency, rated power, then duty rating, which means the amount of time the inverter can supply maximum load. Okay? Then input voltage, then voltage regulation, voltage protection, frequency requirement, power factor and islanding detection. This is very important. So, we will discuss what is islanding and islanding detection. Okay? So, there are different kinds of grid inverters. So, primarily there are 4 categories: module inverters, then string inverters, then multi-string inverters and then central inverters. Let us study one by one. So, what do you mean by module inverters? So, basically these are classified based on the power ratings. Okay? So, here in case of module inverters, this power is varies from 100 to 300 watt and no MPPT is attached in this kind of inverters, and of course, it is a single phase output, and this conversion efficiency was 95 to 96%, and the advantages are no DC cabling are required, easy to add more modules, okay? But major disadvantages are high cost per power rating. This is important, and replacing faulty one is difficult for this kind of inverters. In case of string inverters, we can go power from 700 to 1200 watt, and MPPT is attached in this inverter, and it may be single or 3-phase output. Okay? And the efficiency of conversion, it varies from 93 to 97%. Okay? Advantages are it has a MPPT, readily available, and lower cost per power rating than module inverter. Okay? And only one disadvantage is only one MPPT is attached. Okay? So, even though it is costly, but no, this is really a good one for many of the applications. Next inverter is multi-string inverter. Okay? So, power rating goes from 2000 to 17,000 watt, and multiple MPPTs are attached, and it may be used for both single phase and 3-phase output, and efficiency is about 97%. Okay? So, advantages includes it has got multiple, so it is more precise and readily available, and most importantly lower cost per power rating than module inverter. Okay? And disadvantages are something like more expensive and increases system cost due to use to DC protection on each string. Okay? So, this is one of the disadvantages. And for central inverters, normally for very high power ratings we will go for central inverters. Okay? So, it will be having multiple MPPTs and always 3-phase output will be there, and efficiency is quite good, about 97%, and it has advantages like lower cost per power rating than module inverter. Okay? And can have higher efficiency and one location for maintenance, and only one disadvantage is no redundancy if inverter fails. Okay? So, these are different kind of inverters. So, based on the situation we can select the best inverter for particular application. So, this table shows the comparison of all the 4 inverters. So, we can see the power ratings and we can compare and what condition we need what kind of inverter. Okay? Now, let us understand what is islanding, why this is so important, why this component is need to be attached to its inverter. Okay? For example, a potential danger of grid connected system is islanding. Okay? Imagine that a potential PV system is installed in a street where electricity grid is shut down in order to do maintenance work on the electricity cables. Okay? So, that has to be shut down because no maintenance work has to be carried out in the cables. If it is a sunny day, okay, solar radiation is received by those PV modules, the PV systems will produce power of course and would deliver the power to the grid without protection, right. The electricity worker thus can be in danger. This phenomenon is called islanding, and due to its danger it must be prevented, right. The inverter therefore must be able to detect when the electricity grid is shut down, and the inverter must stop delivering power to the grid. This is very important aspects of an inverter. Normally this component is attached to the modern inverters. Okay? So, we must know what is islanding and what is the potential danger without no islanding. So, now let us learn something about the cables, the kind of cables used in grid connected PV system. Okay? So, this selection of cable plays a key role in the proper functioning of a grid connected PV system. Okay? So, the selection of accurate size and type of cable would enhance the performance and reliability of the PV system, right. The correct sizing ensures very little loss of energy and prevent causing fire due to overheating. Okay. So, the third bullet point is the size of the cable must be large enough to carry the maximum current expected without undue voltage losses. Okay. So, these are very important, and also we must know something on the parameters which depends on like the generating capacity of solar panels, okay, then distance from the solar panel system to the load. Okay. So, this size also depends on these 2 factors. Okay. So, what will be the generation capacity of the solar panel and then the distance, okay, from the solar panel system to the load. Okay. So, these are very important aspect because no it involves lot of cost if we are talking about a megawatt level power plant. And primarily these cables are classified into 2 categories, DC cables and AC cables. Okay. So, DC cables again we have module or string cables and DC main cable, right. So, let us see what is module or string cables. So, as you can see this is module, okay, there are many modules are here and these are the connections. Okay. So, these are nothing but no string cables. So, these cables are usually integrated into the PV panels. So, this is with the PV panels, okay, and it equipped with suitable connectors to be interconnected, right. So, from here to here, maybe this is one panel, this is two panel, so these two are to be connected. So, by using this cable we can connect these two modules, maybe for series connection, maybe for parallel connections, right. So, what is DC main cables? These cables are used for connecting positive and negative terminals from strings to the generator combined box or directly to the solar inverter. Okay. This single wire cables with double insulation are practically proven and offers high reliability. Okay. So, this is also very important aspect which we need to know, and let us learn what is solar AC cables. Already we know once we have inverter, so maybe what we can consider here. So, we have these are maybe modules, okay, modules, and then we have inverter, okay, then we have cables, and then it goes to the load or maybe grid, right. So, this cable is DC cable, right, this DC cable, and this is AC cable. Okay. So, what we are talking about this AC cable. Okay. So, these cables connects the inverter. So, this is inverter to the electric grid through protection equipment. Okay. Of course, there are many equipment will be there in between, and for 3-phase inverters 5 core AC cables are used for connection to the low voltage grid. Okay. And for single phase inverter 3 core cables are used. Okay. So, that also we know when to use what kind of cables. Okay. Now, let us see what is combiner box. This combiner box are used to bring multiple series string together into a single line. Okay. That already we know these modules, and that has to be connected, and finally it will come as a single wire, and where it will be connected, it will be in combiner box. Okay. The strings are typically combined in parallel. Okay. This combiner box are typically located close to the photovoltaic array. Okay. So, this we must know, and these wires from individual PV modules or strings are connected to the combiner box, right, and these wires may be single conductor pigtails with connectors that are pre-wired into the PV modules. Okay. So, already these wires are with that PV module when we purchase the newly PV modules. Okay. A combiner box typically include a safety fuse or breakers for each string. What you can see, these are the safety fuse. Okay. So, these are attached in the combiner box. So, it looks something like this, right. So, there are some connectors. We must know about the connectors, what kind of connectors are used. So, solar connectors are used to connect solar panels to form strings. Okay. So, normally these MC4 connectors are used. Okay. What does it mean? MC4 means multi contact connectors, and 4 means the diameter of the contact pin, right. So, that is how it designates, right. These connectors come in both male and female type, which are designed to snap together. Okay. It looks something like this. Okay. So, female component is male component. Okay. So, these are classified something like this, and these connectors must comply with the following requirements. Okay. What are those requirements? Like stability against the dynamic load, because with respect to irradiance and temperature, the load will vary, right. So, that has to be stable against the dynamic load, right. Then strength, it should have carry some kind of strength, and absolute protecting from dust and water infiltration. Okay. It should not enter water and dust in the connector, and voltage overload stability is also one important factor. Then fireproof. Okay. So, fire no, it should not catch fire immediately. So, an insulent stability to negative effect of ultraviolet radiation. So, these are the requirements no, of a connector. Okay. So, these requirements should fulfill. So, now let us understand the module mountings. Okay. What are different configurations of mountings? Okay. So, as you understand, the grid connected PV system is made up of an array of panels mounted on metallic support or integrated into a building, right. So, we can see some of the configurations. So, this is a configuration for roof mounted. Okay. So, roof is here and parallel to the roof these modules are connected. So, of course, there is a gap and clamps are there to hold the structure, right. So, these are the modules. So, this way you can see different configurations, and here what you can see is a ground mounted system. So, this may be no ground, maybe rooftop, it is a flat ground, and here we need some kind of structure to hold this entire system, and this is at no grass. Okay. So, over the grass this is the installations. Okay. We need this structure to hold this the entire PV system. Okay. So, we will study one by one. So, in case of roof mounted, as you can see here, so this is the modules and this is the roof, and this is parallel to this roof, these modules are installed and there is a gap in between. Okay. So, these PV arrays are fixed to brackets on the roof, generally with a few inch gap and parallel to the surface of the roof, what you can see here. And these roof mounts are less expensive because it uses existing roof structure as a foundation. Okay. So, you do not have to build that structure to hold this entire PV system, right. So, that is one advantage, but at the same time we must be confirm about the strength of that roof to carry that much of load. Okay. So, what are advantages of this kind of configurations? It is less expensive, less material requirement for installation, then labor cost is lower, then utilizes unused spaces. Okay. And what are the disadvantages? This hard to access, especially if the roof is steep or slippery. So, it is very difficult to climb here to fix those panels, and harder to troubleshoot errors. Again, if something goes wrong, then some technician has to visit the site and then rectify the system. So, it is difficult, and space constraints on the roof limits the size of the system. So, if we design a very high capacity PV systems on a small roof, it is not feasible, right. So, that limits the system, and replacement of the roof is difficult within the panel's lifetime. So, once it is removed, then what happens? There might be many operational difficulties. So, it might be some kind of holes, then water when rain falls it may goes in. So, there are many problems. Okay. So, putting holes in the roof could lead to the water leakage. So, these are different problems associated with this kind of roof mounted grid connected system. Okay. So, for ground mounted system, as you can see, we need to have a strong structure, okay, to hold this entire PV panels and other components. Then how we can define it? This PV array are held in place by rack or frames that are attached to ground based mounting supports. Okay. So, again we have to do something here, civil work. Okay. So, cement and other things you need to apply, then we have to have a pole, then a strong foundation needs to be made. So, that involves a lot of cost. This ground mounts take more space, but easier to access for installation and repair. So, this is one of the advantages, and provide greater control over the orientation of PV array to maximize production. Okay. Now, advantages primarily is easy to access, then easy to clean, then easier to troubleshoot, because when dust accumulation will be there. So, every time you have to clean it. Okay? That is why it is very, very important to make an arrangement to clean, so that people can move around and clean it in order to maximize the conversion efficiency. For roof mounted, okay, it is difficult sometimes to clean it. And other disadvantages, like installation is more labor intensive, installation is more expensive, then requires more parts and pieces, not aesthetically pleasing to everyone. Okay? So, sometimes people are claims it looks not good if we install this kind of systems in the maybe near to the playground or near to their garden. So, this is one of the disadvantages of ground mounted PV system. And also we need to have a Scada system for this kind of grid connected PV system. So, what does this Scada stands for? This is something like supervisory control and data acquisition. Okay? And this is used to monitor data from a plethora of devices, including meters, inverters, weather stations, trackers, DC strings and substation equipment. Okay? So, primarily it provides the information about the health of the plant. So, there will be separate rooms. From there they can monitor all those information. Okay? Once you know the kind of radiation is falling, the amount of radiation is falling, what is the temperature, how much energy is generating, all the informations can be monitored by using this Scada system. Okay? So, this Scada provides measurement option for lifetime power production. So, this will be in kilowatt hour, record of daily power production for a month or so, and money saved using solar power, then amount of carbon dioxide reduction, then record of any system warning or fault. So, if some of the component is not working properly, that can be diagnosed, and current system power generation, then total everyday energy production, then photovoltaic input voltage, how much input voltage is generated on a particular day and at particular time, and photovoltaic input current at that time. Okay? So, it looks something like this. It is a very sophisticated. Of course, it needs power. So, that has to be provided from the PV system itself, but this kind of system are very, very important to know the health of the plant. And also for this kind of PV systems, we need weather monitoring stations. Okay? This weather monitoring station is one of the important instruments required for a grid connected PV system, right. So, what information we normally get from these weather monitoring stations? So, we get wind directions, wind speed, temperature, humidity, rainfall, solar radiation and barometric pressure. So, this kind of systems are there. As you can see, this is a anemometer. So, when the wind comes, it strikes on this this is anemometer, this strikes on this bucket and it start rotating. Okay? So, that can we can understand the amount of wind speed on a particular time and day. Okay? And of course, other parameters like temperature, humidity, rainfall, everything can be monitored by using this weather monitoring station. And also there are components like cable glands, these are required. So, small components for fitting tightly all those connectors, and then we need cable lugs. Okay? So, these are something like this. Okay? This is normally used to connect the cables to electrical appliances, other cables, surfaces and mechanisms. Okay? And we will have cable ties and ferrules. So, this kind of components are required to connect those cables. Okay? And of course, we need cable trays for installing those PV modules in this grid connected system. This cable tray system supports insulated electric cable used for power distribution and communication, right. So, as you can see, it is something like this kind of brackets are used. Okay. and then these are holes where when that in order to tighten the system, so nut bolts are provided, and then that will tighten the entire PV system. And one very important aspect is lightning arrestor, which is very important to protect the unit. Okay, so to avoid the destructive effect of lightning strikes, the over voltage protection must be installed at the inverter and at various other locations in the PV facility. So this is very important, because without arrestor it is very risky, otherwise all the things will damage. Okay, so lightning arrestors are primary, and of course fuses are required. So these fuses plays a very important role in solar power projects. So there are different fuses, like in AC fuses are different as compared to DC fuses. So as per requirement, so these fuses are installed in the prominent places, and this will protect the equipment for a longer life. Okay. So we can summarize what we have discussed today. Primarily we have discussed the functioning and layout of grid connected PV system, and then we have understand the different components of a grid connected PV system, then how this can be selected, and role of different components for maximization of PV system efficiency. I hope that you understand the things very clearly, and maybe in the next class we will study more on design aspects of grid connected PV system. So thank you very much for watching this video.